Okay, here we have section 9.5, simplifying complex numbers. So add, subtract, multiply, and divide complex numbers in rectangular form. So complex numbers are numbers that have the form a plus bi, where a and b are real numbers, and I as the imaginary unit is defined as I squared equals, well, this should be -1, the negative sign, kind of wrapped around there. So that means this is also true. The square root of -1 is equal to I, because if you square both sides, you get this expression. Okay, to simplify basic terms, to find the value of any power of I, you're going to let capital R be the remainder when the exponent itself is divided by 4. So if the remainder is 0, you get is equivalent to 1. If the remainder is 1, it's equivalent to I. If it's 2, it's -1, and if it's 3, it's -I. Now, when you do this in your calculator, this will be some number that ends in 0.25. This will be some number that ends in 0.5, 0.75, and this value will have no decimals values at all. Okay, so let's look at these examples. So simplify each power of I. So you have I to the 53rd. So what we need to do is we're going to need to take 53 divided by 4. Get 13.25. So that's an R value of 1. So an R value of 1 means we have just I. So I to the 53rd is the same thing as I. So I to the -13, we're going to do the same thing, -13 divided by 4. That is -3.25. So R is once again 1. Now the trick is you've got this negative value here. That means your I actually sits on the bottom of the fraction. So instead of it being I, it's going to be 1 over I to the first. Okay. So we've got some other more algebra type simplifying of each expression. So the first we've got addition, you've got subtraction, you've got multiplication. And so for addition and subtraction, you're just combining like terms. So 5 plus -2, that's 3. -3 plus +4, that's 1, so 3 plus I. Subtraction works the same way. 10 minus 14, that's -4. -2 minus -6, so that's -2 plus 6. So that's 4. Now for multiplication, you have to FOIL. So firsts gives me 14. Outsides, -8i. Insides, -21i. And lasts, +12i squared. There's a couple things that need to happen here. First of all, these two middle terms are like terms. So you have that. Next, this I squared is the same thing as -1, which makes this 12 turn negative. And lastly, now I have two more like terms. I combine 14 minus 12, that's 2. So that is the simplified version. Okay. Division works a little bit differently. It uses what's called complex conjugates. So if you have one number that's a plus bi and a minus bi, those are complex conjugates of each other. So all that's different is the sign in between or in front of the imaginary part of this term. So in order to divide by a complex number, you have to multiply both the numerator and denominator by the complex conjugate of the denominator and then simplify that problem. So here we go. We've got this. So here's your problem. So I'm going to multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate differs in sign. So both get multiplied by 1 plus 2i. So across the top, this is a FOIL problem. 5 times 1 is 5. 5 times 2i is 10i. -3i times 1 is -3i. And that's going to be, let's see here, -6i squared. On the bottom, I have to FOIL as well. So 1 plus 2i minus 2i minus 4i squared. So on the top, those middle two guys are like terms, so that's on the bottom, the middle two are like terms. so they go away. These are opposite in sign. Now this is 5 plus 7i plus 6. The I squared flips the sign. Same thing down here. And then your last step, you combine like terms, 11 plus 7i over 5. Note that the I term always comes last. Now there is kind of a little bit of a trick for the denominator. If you saw, that's a whole lot of work to get down to just a number. That's actually always true. If you have a plus bi times a minus bi, this is always equal to a squared plus b squared. You ignore the I. So in this case, in my problem up here, a is 1 and b is 2. So 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. So here's just some general rules if you want to think about them in terms of the coefficients. It's just showing that you combine like terms. The FOIL will always work out to be this thing, or the complex conjugates always work out to be this thing. If you notice, this is written as two separate fractions, but they have the same denominator, so it's over a single fraction. Either way is correct. So that's all for section 9.5.